Hello, everyone. We are adolescents from the Blue Blocks Montessori School. So we adolescents will now present a skit which we named From the Cube in the Hands to the Cube in Space. Lights, camera, action. In primary, we had built with the hand. And through the hands, the mind awakened. In elementary, the hands gave way to the mind. The cube opened and patterns were revealed. And in Erdkinder, the cube, the same cube, demanded more than understanding. We adolescents stood at the threshold of the world where ideas must become action. What had been built by the hand and refined in the mind now took form as a CUBESAT, asking for courage, collaboration, and responsibility to carry human thought to the service of the earth and into the wider universe. The legacy of this cube passed from the largest cube of the Pink Tower in primary to the binomial 10th cube in elementary to the CUBESAT we built in the present. This was how Montessori learning built the foundation for what we built today. Now, let us show you how we built this CUBESAT.
I'm Sanjay from Blue Blocks. Here we are in our space lab doing something extraordinary, something absolutely out of this world, something no one thought we could actually do.
Okay, so do we want to show it to the world?
Yes!
All right. So we are building a real cube satellite which we're actually going to send to space. This is the port key, the CubeSat. The CubeSat has 4 different aspects to it: programming, circuit building, fabrication, and quality and testing of our CubeSat project.
A CubeSat is, you all must have heard of a satellite, right? The huge instruments that go to space, do a lot of experiments, have a lot of sensors, and that costs a lot. So those satellites do a lot of things. They help us in everyday world. They help us travel. They help us do a lot of other things. We decided to make a CubeSat. So a CubeSat is almost the same thing as an actual satellite, but compact.
So we have 4 different sensors to stuff in our satellite. So the first thing we're going to stuff in the satellite is the ultraviolet sensor. You can see the violet color here. So the job of this sensor is to detect UV radiation. So if while cantering around in space, it suddenly got a huge wave of UV radiation, we in Earth, getting the data from the CubeSat, can interpret that it's probably near a star. After that, we have the accelerometer.
So this is a gyroscope and it has 3 axes. So this is X, Y, and Z.
So this is the electronic gyroscope which measures rotational missile. It has 3 axes, X, Y, and Z. If I rotate it like this, it will show movement in one of the axes. If I rotate it like this, one axis. If I rotate it like this, another axis. So how it works is this has a power supply and this is a buzzer. This is a 9 gate and these are wires and this is the infrared sensor. 0, 1, 0, 1, 0, 0, 1, 1, 0.
So building circuit boards using soldering is one of the many vital skills required to fabricate our CubeSat. The solar system. And in this solar system lives our Earth. And from this Earth will come our CubeSat, revolving around Earth, gathering data, and us interpreting it.
We are inside the Mission Control Center of Sriharikota. You can see the screens behind. So we are quite a few of us in the gallery here.
Hello. Now you saw how our CubeSat was built. Now, let me take you to Sriharikota at January 12th, 9 a.m. So, we were in front of the prestigious gate of the core ISRO facility in Sriharikota when we stepped out of the car and showed our passes to the security. I felt my heartbeat change. It was like crossing into another world. So, and when we reached the mission control room, the building, it looked less like a building. It looked more like a spaceship itself. Inside, scientists were moving around in tight clusters, discussing formally and scientifically. We made our way to the second floor, and when the VVIP gallery door opened just for us, we froze.
As soon as the doors opened, there was a big red carpet with luxurious seats all around. You saw that. And a big glass where the other side was the mission control. Huge screens where data showed all angles around the rockets, and everything was surreal for a moment. Everything didn't feel possible, but here we are.
So in there, we talked to the scientists. Their calmness, their clarity, it was unbelievable. We talked to them. We saw the data and checklists on the huge screen in the mission control room. We tried to decipher them using our academic skills, and it was really fun. And then came the part that felt unreal. The ISRO chairman met us and met Pavan sir, and he knew that our CubeSat was flying in the PSLV C-62nd mission of the rocket, and that was a really surreal moment for us. And the entire deciphering of the graphs, it felt like textbooks coming alive.
So almost when the T-minus 5-minute announcement came on the radio there, everyone, all the VVIPs there rushed out. There was a small balcony where all of them could go and then watch the rocket actually launch. We stayed inside for a little bit longer because we wanted to see the graphs. So at the last 30 seconds, when we stepped out, everything just, it felt like time started going faster. It felt everything was shifting before us, and
the final countdown started before 10:18 a.m. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then it happened. The rocket erupted out of the greenery with a blazing flare. And after 5 seconds, the entire balcony reverberated. The vibration tore through our chests and into our hearts, and the sound throbbed across the entire room. Everyone around us had gone crazy for that one moment, clapping, cheering, yelling. And in no time, the rocket had tore through the clouds and disappeared in the skies. And everyone came back to their formal selves again and rushed inside the VVIP gallery.
As soon as they went inside, updates started coming in from the rocket. First, stage 1 deployed successfully. There was a loud applause from everyone. Stage 2 initiated. Another loud applause. But then it happened. At stage 3, at the end of stage 3, there was a small rocket failure. There was a fuel burnout where the rocket could not actually go to the desired orbit. Stage 4 could not deploy, it could not initiate, which didn't make our satellite actually go into the correct orbit. So,
when we got to know that our CubeSat wouldn't reach the designated orbit, we wouldn't get the data which we really wanted to receive. And more than our heartbreak, of course, we were heartbroken for a while. But after that, we realized how much the ISRO scientists faced, because they had been working on this rocket and their main satellite for at least a few years, while we had been working for a few months. So they must have been feeling much more worse than us, and our heart reached out to them. Our hearts were actually wrenched and wrung when we had to leave the facility. But then Pavan sir stopped us and reminded us that our CubeSat had passed every space-grade test. Vibration, pressure, extreme temperature. It was space-worthy. ISRO had believed in us. And the assistant director of InSpace had reached out to us and even offered us their help. They motivated us to build another CubeSat, to build a better, bigger, foolproof one. They even offered us access to their ISRO experts.
And that's how a new satellite, SBB-2, was born. Bigger, stronger, smarter. This satellite will be built from the fear that we went through, but from the success and all the experience we gained. We'll take all of that, build another satellite, and show everyone what we can actually do.
So when we are going to send SBB-2 to the space, and we're going to receive data from our second satellite, we're going to share it with the world. And that's our contribution to the theme of this conference, Superior. Thank you.